Uh, in my semester, uh, I was just introduced to a new subject called design thinking, and we were given some domains related to which we have to make some sort of models or prototypes. I can say my team chose a domain related to safety, and the name of our project is Advanced Smoke Ventilation Automated Rapid Exhaust System. So now this system basically consists, or you can say the main idea of this system is to evacuate out the smoke from a room or a given hall with the help of exhaust vent and sensor. So basically, sensor will sense the smoke and it will give signal to our, exhaust vent, and it will suck out the exhaust smoke from which people will get relief from, the smoke they're facing. So to make a prototype, we have used, uh, obviously, MQ2 pinout sensor, Arduino, a 12-volt fan, and a relay module. So we can say that if we have used a 5-volt fan, then we don't need the relay stuff here. But as we have used 12-volt fan, so we are using a relay to support the running of 12-volt fan with the help of Arduino. Uh, if we go to the connection stuff, the more technical stuff, we will see that for this we have to understand the basics of Arduino, like we have digital pin, analog pin, and this power pins. So yeah, from input we can say the sensor will take input from the environment. So yeah, sensor. If we introduce the MQ sensor here, it has four pins: VCC, ground, DO, and AO. We can say A0. The digital pin DO or D0 and analog pin A0. If we jumping straight to the connection, the sensor will first connect to Arduino. The VCC here, we have VCC of the sensor. It will connect to 5-volt here of your Arduino. Then we have ground of the sensor. The ground will connect to here, the ground of Arduino. Then we have digital pin. Now to run this Arduino and so to run this sensor and Arduino, we need some sort of code blocks, or you can say we need some code. So in my code, I have given the digital pin or the digital power of sensor to the second D2 section or D2 pin, and A0, as it suggested A0, I have given here A0 to another pin. So this is how our connection of sensor and Arduino will work. The VCC to 5-volt, ground to ground, A0 to A0, and D0 to DO2. Here we have DO2. Now, the input of relay. So here we can see the input of relay. Again, VCC, we will connect it to 5-volt of Arduino. Now, basically, to connect this, we need breadboard. As we are using same 5-volt terminals or from the Arduino, we can use breadboard to connect it in parallel, so we can have equal 5-volt distributed to both relay and sensor, right? And again, ground, the same ground of relay to here. We have ground here, ground. Yeah. So this is how our input work. Yeah. Now, again we have DO, which is IN. I have written here in connection IN relay means input of relay will connect to digital output of our Arduino, and according to the code that I've written, I have attached it to pin D5 basically. So yeah, here I have written as per my code requirements. If you are writing code according to your requirement, you can change it from 7, 6 or anything you have. Okay, so now we will jump to output connection. Uh, Now, as I said, I have used a 12-volt fan. So we will obviously need a relay to and this to run its mechanism, to run the fan basically with the help of the mechanism of Arduino and the code I have written. So here in output, these are the output pins, right? One is NO, one is CO, and this is NC. So I don't know what's written here. It's a different language, maybe Chinese or anything. So this the middle screw or the middle connection is always of COM, right? Common, or we can say ground. So my fan has basically two wires, means two terminals. One is one has of black wire and another has of red wire. So it's quite natural from your the color coding system that your red is for live and black is for generally neutral. So yeah, the middle portion, which is COM, it will directly get connected to our black wire, right? Neutral wire here. We don't need any sort of battery or adapter here. But if we go down to NO means the circuit has now started flowing or giving the output. So we have at the end of the day we have to give output to the fan, and we will give it with the help of relay. So we will use the NO terminal will connect NO, which will connect it to positive terminal of the battery, or we can use an adapter. Because I have used the 12-volt battery, 12-volt fan. So in case of 12-volt band, I will use a 12-volt battery. If you have any other sort of load which requires any other sort of voltage consumption, so you can alter your voltage regarding to that. Yeah, so here we have anode to battery's positive terminal. Now the battery's negative terminal will get attached to, or will get connected to the red wire, or you can say the live wire of the fan. And from this connection, our fan, the whole connection or the whole technical setup will take place. And from there, I can insert I've written a code here. This is for sensor, which has, I've told before that I've used second pin, and for relay, I've used the fifth digital output pin. And I have here threshold of 150. So the ampere sensor basically senses the air quality in ppm, right? So it's about 150, about 1500,000 ppm or something. So when it will sense the threshold value, here in code I have written, when it will sense the value from the sensor, which is known as analog value. And if in case analog value is greater than the threshold value that we had already kept as 150, then our fan will start working, right? And if it can't sense the, obviously if it can sense, then we can find any output from the side of fan, so the fan won't work. But I have here kept a delay of 5 seconds, that after discovering the threshold sorry, the analog value greater than the threshold value and the smoke. So the fan will run after 5 seconds extra, after we have analyzed the smoke, or we have detected the more greater value of the smoke, right? And after every 0.5 second, the sensor will sense the air quality that we have. Now I have already a practical demonstration, a video demonstrating the practical of this project, and yeah, I will show it to you. So yeah, this is our project based on smoke ventilation. Here you can see the threshold of smoke is 175, and it can detect smoke in real time. So yeah, the fan is off because of the quality of air is literally clean here as compared to 175. And here's the setup. Consists of Arduino, a breadboard, some jumper wires, sensor, ambient sensor for detection of smoke and gases, a 12-volt exhaust fan, whereas we have a relay module here and a battery here in the whole connection. This was the whole technical part, and this is the body of the project, right? So we have a smoke source here. We're putting it in the room and closing its case. Yeah. So as you can see, the value of the smoke, the quality of this air is increasing, and it's not yet
transcending 175, but yes, still it's increasing. Yeah, now it has transcended 175 and the smoke and the fan is running here. You can see this fan is running. Yeah, yeah, it has now off. Now the delay in time of the turning off the fan was because we have here kept the delay of 5 seconds, right? And the sensing of smoke is in 0.5 seconds. So yeah, again you can see we don't have the threshold value across 175, but as it crosses the 175 value, the fan will again turn off. We can wait here for some time. Yeah. Yeah, you can see here that the value is closed, and yeah, the fan is running here. You can see. Yeah, now the fan has turned off because yes, now again the fan will run. So yeah, our main objective of automatic smoke detection and exhaustion system has like we have achieved that. So and it's pretty much valid that the sensor is working. And yeah, thank you.